employ Euler's formula to show that sine alpha plus sine beta equal 2 times sine alpha plus beta divided by 2 and time cosine alpha minus beta divided by 2. Prove. Euler's formula is e to the I theta cosine theta plus I sine theta, and I is defined as square root minus 1. But in engineering society, they use notation J equal square root minus 1. Now, from this equation, we can get the following two equations. One is cosine theta equal half e to the I theta plus e to the minus I theta. Now, sine theta equal 1 divided by 2I e to the I theta minus e to the minus I theta. What we need to prove is the following. We need to prove sine alpha plus sine beta equal 2 times sine alpha plus beta divided by 2 cosine alpha minus beta divided by 2. To prove this identity, we are going to work on the right side. So we want to prove that the right side is equal to the left side. So right side of this equation equal right side equal 2 times sine alpha plus beta divided by 2 cosine alpha minus beta divided by 2. And we use this expression for cosine and this expression for sine. So we have this equal 2 times two I e to the I. Now theta equal this one, alpha plus beta divided by 2 minus e to the minus I alpha plus beta divided by 2. and time cosine. Cosine, we use this expression. So we have here is divided by 2 e to the I alpha minus beta divided by 2. We put substitute on here. So here we have 2 alpha minus beta plus e minus I alpha minus beta divided by 2. Now we need bracket on here, bracket on here, we need bracket on here, we need bracket on here. Now we simplify further. So we have this 2 cancel with this 2, and this 2 I here, so we write down, I put in the front 2I. Now so this term we can simplify as e alpha divided by 2 times I e I beta divided by 2 minus e minus I alpha divided by 2 e minus I beta divided by 2. Now this term e I alpha divided by 2 and e minus I beta divided by 2, and here's plus e to the minus I alpha divided by 2 e plus I beta divided by 2. And one divided by 2I so this term times this term alpha divided by 2I e to I beta divided by 2 like time this term e to I alpha divided by 2 e to minus I beta divided by 2, then plus this time this one e to alpha divided by 2 times I e to I beta divided by 2, then time this term e to minus I alpha divided by 2 I beta divided by 2. Now, and then this time this term. So minus e to the minus I alpha divided by 2 e to the I beta divided by 2 times this term. This term I alpha divided by 2 minus I beta divided by 2. Now this term times this term. So minus e minus I alpha divided by 2 e to the minus I beta divided by 2, then time this term. This term e to the minus I alpha divided by 2 I beta divided by 2. Now bracket. So this term I beta divided by 2 and minus I beta divided by 2. So this term cancel out with this term. And this one, alpha divided by 2 times I minus I alpha divided by 2. So this term cancel with this term. And this minus I alpha divided by 2, here's plus I alpha divided by 2. And minus I beta divided by 2, I beta divided by 2, this cancel out. So I just simplified as one divided by 2I e I alpha plus e I beta minus e to minus I beta minus e to minus I alpha. One divided by 2I e to I alpha minus e to minus I alpha. I just alpha e to the alpha I put here, and the minus e to the minus I alpha I put here. Then plus e to the I beta minus e to the minus I beta. So this equal e to the I alpha minus e to the minus I e to the I alpha, then 2I divided by 2I plus I e to the I beta minus e to the minus I beta. Now the first term e to the I alpha minus e to the minus I alpha divided by 2I. According to this formula, equals sine alpha. And this formula, according to here, this equal plus sine beta. So we just prove that the right side equal to left side.